Hi everyone, we're going to apply the difference quotient, and we've already learned that this is actually the slope formula rewritten. H can't equal 0, and we've got three equations we're going to apply it to, and then take the limit. This is called the derivative of the function. So when you take the limit of the slope here, as h approaches 0, or the difference quotient, you will get the derivative. So let's start with the first one. We have f of x equals 2x. And we have our difference quotient is f of x plus h minus f of x divided by h. So we do this in two pieces. First, do this part. So plug that in, and you're going to get 2 times x plus h. Now we're going to do this part minus 2x divided by h. Okay, then we're going to apply the limit as h approaches 0. So simplifying the numerator, we get the limit as h approaches 0 of 2x plus 2h minus 2x divided by h, which equals the limit as h approaches 0, the 2x's cancel, 2h divided by h. Okay, so now write the limit again. And these h's would cancel, changes the domain, and we get 2. Based off our limit laws, then this is going to equal 2. That means the derivative, so f prime of x equals 2. So the derivative, if this is our function, then our derivative equals 2. Okay, let's do the next two. So we do the same thing. Our problem is f of x equals 3x minus 1. Our difference quotient is f of x plus h minus f of x divided by h. So the first part is you're going to plug this in to this x. So we can get 3 times x plus h, and then you subtract the 1. So we did of f, so basically you're just plugging f of x plus h for the first step. Now you subtract the whole function. So I put brackets here, so that's going to be 3x minus 1, all divided by h. And this is your limit as h approaches 0. All right, now let's simplify the numerator. So we get 3x plus 3h minus 1, and don't forget to distribute this negative, minus 3x plus 1 divided by h. Simplifying your numerator, don't forget to keep writing this limit. These cancel, the 3x's and the 1's. So we get 3h divided by h, and that's going to give us the limit as h approaches 0 is 3, because the h's cancel. So that means when you apply the limit, you get 3. That means if f of x equals 3x minus 1, then the derivative, or f prime of x, equals 3. And the last one, we're going to do the same thing. We have f of x squared plus 2. So I'm going to apply the difference quotient, which is f of x plus h minus f of x divided by h. So let's just write it all out. The limit as h approaches 0. Now let's do this first part. So this first part you take separate. Just act like we're not doing the others yet. So everywhere there's an x, I'm going to put parentheses plus 2. And we're going to input x plus h. So that's the first part. Then we're going to subtract the whole function. And our whole function is x squared plus 2. All right. So let me rewrite this too. This is f of x equals. All right. Now, this is all over h. And we simplify the numerator. Make sure by this time you know how to do your factoring facts. So this is just going to be x squared plus 2xh plus h squared plus 2, and then minus x squared minus 2, all divided by h. This simplifies the limit as h approaches 0, and we can cancel things out. Now, a good rule, it's actually a rule of thumb, everything should cancel out that doesn't have a h in it. If it doesn't, then you did something wrong. So basically we get 2xh plus h squared divided by h. Now I'm going to factor out an h from the numerator. That gives me 2x plus h divided by h. So then when the h's cancel, you're going to get the limit as h approaches 0 of 2x plus h. Now we can apply the limit, plug this 0 into the h, and we get 2x. So that means the derivative equals 2x for this function here. And that's it. Thank you. Have a nice day. Bye-bye.